There, we start off with our third class of the chapter Permutation and Combination. And in this class, we are going to talk about permutation part 2, that is permutation of objects which are not distinct. So, what happens when we have objects when we are arranging may not be distinct? So, let us explore. So let's say I have n objects, and out of these n objects, p objects are of one type, q are of second type, and r are of third type. Then rest of them are different. In that case, the total number of permutation of all the n objects taken all at a time will become n factorial by p factorial into q factorial into r factorial. So this is the situation which we can give example by taking some of them. The first one, let us take the word exhibition. Now the word exhibition, you can see that all the letters in the word exhibition are not different. There are certain letters which are same. For example, in this word we have the letter I, which is repeated 3 times. So therefore, if I want to find out what is the total number of permutations when I'm trying to arrange all the letters of this word, then that will be given by 10 factorial by 3 factorial. 10 factorial for 10 different letters we have, and divided by 3 factorial because 3 of them are similar. Similarly, let us take another example. Let us take the word Kolkata. Now in this word we have 2 different kinds of similarities. One is K. There are 2 different K's and there are 2 different A's. So therefore, the total number of permutation of this particular word, or I mean the letters of the word, is going to be 7 factorial by 2 factorial into 2 factorial. So the first 2 factorial is for K, the second 2 factorial is for A. Right? So this is just all you have in this particular topic. So let us take few problems and understand. So let us take the first one. The first one is, in how many different ways the letter of the word algebra can be arranged in a row if the 2 A's are together, and in the second case the 2 A's are not together. So let us first find out how to get the first one, that is if the 2 A's are together. Now the total number of permutation, that is all different kinds of permutation of the word algebra, is given by 7 factorial by 2 factorial. Why that 2 factorial? Because there are 2 A's. So those 2 A's account for that 2 similarity. So therefore divided by 2 factorial. Now if I'm talking about 2 A's coming together, so you already know how to work with that. So let us consider both the A's as one unit, and something like this. If I am considering these 2 A as one unit, and then there are 5 places to cover up, I mean 5 places to permute, then total you are actually permuting 6 different places, and all these 6 places are different because I have already considered these 2 A's as one unit. So therefore the total number of permutation is going to be 6 factorial, that is 720. Then the total number of permutation when both the A's do not come together, then it will be the total number of permutation minus the case when the 2 A's are coming together. So that is 1800. Fine. Let us move to example 2. In how many ways can the letter of the word assassination be arranged so that the S's occur together? Now the same way we do it, let us consider that the 4 A's to be one unit. One unit means it's just one particular element, and then the word assassination has got 6, 7, 8, 9 and 4, 10, 11, 12, 13. So there are 13 letters in the word assassination. of which 4 letters, that is the 4 different S's, we are considering as 1 unit. So therefore you have to arrange rest of the 9 places. So in total, how many places we are arranging? We are arranging 10 places, so that can be done in 10 factorial ways. Now, in all these places that is left, the different letters that we have, if we look into it, we have 3 different A's, then we have 2 I's and 2 N's, and what else? Nothing else. Like I have 3 different A's, 2 different I's, and 2 different N's. So therefore all these are similar, so I have to divide the whole thing by 3 factorial, 2 factorial, and 2 factorial. So therefore the total number of permutation is 10 factorial divided by 3 factorial, 2 factorial, 2 factorial, that is this 151200. Right? Let us move to number 3. How many numbers greater than 1 lakh can be formed by using the digit 242302 taken all together? So you are given a set of digits. I have to form numbers more than 1 lakh, and how to do it. Now in this case there are digits repeated, so I have to take different cases. See, the first thing is that for any number to be greater than 1 lakh, it must start with 2, 3, or 4. Now let us take different cases and understand how it works. So let us take the case when it starts with a 2. So if the number starts with a 2, so let me take this 2, gap, 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 right? So I have to fill up these 5 places. Now while I am filling up these 5 places, how many ways I can fill? So you see, leaving these 2, there will be 5 more numbers left. Now of these 5 more numbers, there will be 2 repetitions. So there will be 2 2's. So therefore this will become 5 factorial by 2 factorial. That is exactly what I have written. Fine. Next, if it starts with 3. So once again, if it starts with 3, then 1, 2, 3, 4, 5. Now in these 5 places, when I am arranging, there will be 3 different 2's. So as there are 3 different 2's, it will become 5 factorial by 3 factorial, right? And then finally, the same thing happens if it starts with 4. It will be 5 factorial by 3 factorial. So if you add them up, we get total number of cases 60 plus 20 plus 20, that is 100. Fine. Next, number 4. How many arrangements can be made with the letters of the word mathematics if there is no restriction, vowels occur together? So let us take one by one. If there is no restriction, that is, if I am taking all the letters of the words at a time, now how many letters are there? There are 11 letters. Now we have to check how many repetitions are there. 2 M's are there, I can see. 2 T's are there, I can see. And also 2 A's are there. So therefore, it will be 11 factorial by 2 factorial, 2 factorial, 2 factorial, and this is the number. Next, vowels occur together. Now, in case of vowels occurring together, this is the situation you have. Now, this is something we need to put some stress on. Now, considering this as whole 1 unit, and you have got 7 more places to fill up. So all total you are filling up 8 different places. So therefore it will be 8 factorial. Fine. Now 8 factorial divided by, in this place, how many repetitions are there? There are 2 T's and 2 M's. So therefore I will have 2 factorial, 2 factorial, right? Now all these 4 vowels can arrange within themselves in how many ways? Now as there are 4 different vowels, they can arrange within themselves in 4 factorial ways. But there are 2 A's, so therefore divided by 2 factorial. So this is the total permutation or the number of ways vowel can occur together. So that's exactly what I have written, and the value is 120960. Fine. Let us move to the third one. Now, the third one is all vowels don't occur together. It is pretty easy to solve. The first one, that is when there is no restriction, minus the case when all the vowels occur together. So if we just subtract the letter from the previous one, then I get the answer. Let us move to the fourth one. Consonants occur together. So now to see, these are the consonants, you see. Now considering the whole bunch of consonants as one unit, I have left four more places to arrange. So in total I am arranging 5 different places, so 5 factorial. Now among these empty spaces I have all the vowels fitting, and of all the vowels there are 2 different A's, so therefore here it should be 2 factorial times. Now these consonants can arrange within themselves in their own ways. So how many ways there are? How many consonants? 1 2 3 4 5 6 7. So 7 consonants divided by, there are 2 M's and 2 T's, so 2 factorial and 2 factorial. Fine. So whatever this is, whatever it gives the value, and that gives you 75600. So that's it. And then number 5, M is on both the extremes, both the M on both the extremes. Now in that case, leaving those 2 M's, there will be 9 places to fill up, and all those 9 places can be filled up in 9 factorial ways. But there are 2 A's and 2 T's, so therefore 9 factorial by 2 factorial into 2 factorial, and that is 90720. The last one. Now before going into the last one, let me just remove this. Let me just make you understand how the last one works. The last one is order of the vowels remain unchanged. Order of the vowels remain unchanged means, so let us go back to the same condition, A, E, I, and then 1 2 3 4 5 6 7. So this is the condition we are talking about. Now the order of the vowels do not change means it really does not matter in which way the vowels are, but the vowels will be in exactly the position they are. So if A, E, I, if it is in this order, then it will be in this order for all the cases, or if it is E, A, I, E, I, A, then it will remain in that order for all the cases. So that means the order of the vowels is immaterial. So that is what it means. Order of the vowels remain unchanged. That means it is immaterial in which order the vowels are. So we are not going to consider any these vowels as a particular different elements. I mean, we are not going to consider each and every single vowels as different. So if we don't consider each and every single vowels as different, then all these 4 vowels can be considered as one thing. Then therefore what happens, in total I have how many places to arrange? I have 11 places to arrange, considering 1 2 3 4, and then there are 7. Now of these 11 places I have 4 things of one type. These 4 vowels, they are of one type, so therefore 4 factorial. Then there are 2 M's, so 2 factorial, and 2 T's, so 2 factorial. So this is the case when the order of the vowels remain unchanged. If I would have been given the question that if order of the consonants remain unchanged, the same thing would have happened. 11 factorial. Now there are 7 consonants, considering them as same thing, so it would have become 7 factorial, and there are 2 different A's, so this would have become 7 factorial into 2 factorial, right? So let me just finally write the answer. So this is your answer, right? So that's it. That is the class. It was a short class which completes the topic of permutation. In the next class, we are going to start off with combination, and that will be the last class for this chapter. And as always, if you have any doubt, please get it clarified. Thank you.